For lesson 3, we're going to take a look back at the relationship between slope and rate in terms of rate of change. So, Robin is preparing to make taquitos for supper. She preheats the oven to 400 degrees Fahrenheit. The graph represents the temperature of an oven as it's warming up. What does the point of 0 and 50 on the graph represent? The oven starts at 50 degrees Fahrenheit. So that is when the oven is basically turned off. What does the point of 5 and 400 represent on the graph? After 5 minutes, the oven heats up to 400 degrees Fahrenheit. If I'm calculating the slope, well, my slope is going to be 400 minus 0 divided by, minus 50 divided by 5 minus 0, or 350 over 5, which is going to give me a slope of 70. The slope represents a rate of change, a change in the temperature divided by the change in time. What units are used to represent this rate of change? Well, my y values are all in degrees Fahrenheit, and my x values are all in minutes. Which means that, in this case, the temperature is increasing at a rate of 70 degrees Fahrenheit per minute. For part 2, water is leaking out of the bottom of a barrel at a constant rate. After 2 minutes, the water level is 62 centimeters. After 7 minutes, the water level is 22 centimeters. On the grid, we're going to plot the ordered pairs where our time is going to be x values and our water level is going to be the y values. So here I have water level in terms of centimeters, and here I have time in terms of minutes. And I have my points. The first one is 2 minutes and 62 centimeters. And the second one is going to be 7 minutes and 22 centimeters. If I connect these points, then I can calculate the slope of this. The slope is going to be 22 minus 62 over 7 minus 2. It gives me negative 40 over 5, or negative 8. The slope represents the rate of change, a change in water level divided by the change in time. What are the units to represent this? Well, in this case, it is in centimeters per minute. So in this case, we could either say that the water level is changing at a rate of negative 8 centimeters per minute. Or if we state that it's decreasing, we know that it's going to be negative, so it's decreasing at a rate of 8 centimeters per minute. If we state that's decreasing or increasing, we know whether it's negative or positive, so we don't need to state a sign. In the previous investigation, we discovered the following: that slope is the same as the rate of change. A rate of change can be used to describe many scenarios. For example, change in distance over time, change in temperature to time, change in salary to change in sales, yada yada yada. A positive slope indicates a positive rate of change. A negative slope indicates a negative rate of change. On a graph of distance as a function of time, the slope of a line segment joining these 2 points represents the average speed, or if we're thinking in terms of physics, average speed or velocity, as illustrated in this example. Dave entered his car in a long-distance car race. He traveled the first 150 kilometers in 2 hours, and after 6 hours, he had traveled 650 kilometers. If we're plotting ordered pairs to represent this information, then we are going to state that this is going to be my distance in kilometers, and this is going to be my time in hours. Then I need to figure out how I can fit all this data in. Well, we know that the distance goes all the way up to 650, which means that I'm going to start at 0, and then if I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 lines, then every line is going to be worth 50, or every second line is going to be 100. On the bottom, I'm going to say that every second line is going to be 1, 2, 3, 4, 5, 6, all the way up to 7. I'm going to plot the points that exist on here, and I know I'm going to include the point of 2 and 150. I'm going to include the point of 6 and 650. And I'm going to include the point of 0 and 0 because after 0 hours, he hasn't traveled anywhere. If I'm calculating the average speed between 2 hours and 6 hours, then what I'm actually searching for is what is the slope between 2 hours and 6 hours. So the average speed is going to equal 650 minus 150 over 6 minus 2, which would be the same as 500 over 4, or 125, and then I just need to put in the units, kilometers per hour. By looking at the grid without doing any calculations, how can we tell if the average speed between the first 2 hours was less than the average speed in the next 4 hours? Well, in the first 2 hours, I went from this point to this point. In the second 2 hours, I went from this point to this point. How do I know that the speed is faster in the next 4 hours, the slope is steeper in the next 4 hours. The graph shown represents the amount of fuel in Dave's gas tank as a function of the distance traveled during a portion of the race where he drove at a constant speed. So first we're going to calculate what the slope of this line is. Well, the slope is going to equal 40 minus 50 over 120 minus 20. This is going to give me negative 10 over 100, or negative 1 over 10. If I'm doing it based on the units, I would actually divide this out and say negative 0.1. The amount of fuel in the tank is decreasing. The rate of change of the fuel is going to be negative 0.1 liters per kilometer. The amount of fuel in the tank is decreasing at a rate of 0.1 liters per kilometer.